All right. Hi, everyone. And thank you very much for the introduction. Thank you for the invitation to be here. And I'm going to talk a little bit about the FRP codes in Brazil and South America, mainly in Brazil. And actually, I'm going to focus on internal reinforcement of concrete structures. So just to let you know that the Brazilian the concrete structures codes in Brazil are well consolidated. So it started in 1940s, and now we had a recent version in 2023. And in 2008, the code was recognized by ISO. And also, if you take a look into the codes in South America, you see that they are pretty recent and pretty modern codes. Of course, there are exceptions. I was talking to a friend from Uruguay, and he told me that the concrete structures code in Uruguay was released, the first one was released in 2001, and it doesn't include prestressed concrete. And so he told me, Mira, Daniel, we don't have anything about FRP here. Our code was born old, just like Benjamin Button. So we have exceptions, of course. And in South America, before 2018, we didn't have anything, just one manufacturer of FRP, and mainly the main application was in soft ice for tunnel constructions, and eventually on industrial projects. In 2018, for some reason that I don't know, many manufacturers started to bring, suppliers started to bring FRP bars from Russia to Brazil, and we saw a proliferation of FRP bars in Brazil. And after 2018, with the pandemic and the higher cost of steel, people started to pay attention to FRP, but actually not for the right reasons. They are trying to reduce the costs. And after we had the Ukraine war, which increased the cost of FRP bars imported by Russia, and then we saw growth of national companies, and we see that we have limited knowledge and qualified personnel. And also what we see right now is the main application is grids for slabs on grade. But we see applications even on lintels. It's just a variety of applications. And so about the timeline of our code, this is mainly the FRP reinforced concrete code. In 2015, we had the installation of the Ibracon ABS TC 303. Ibracon is the poorer brother of ACI in Brazil. Okay. And it's basically non-conventional materials for concrete structures. We have 5 working groups, and the third one is about the FRP-RC. 2019, we had that working group restarted after a long break. 2021, we developed a manual of PRETs, what you can see on the right. And after this manual was released, we installed Brazilian Standard Association committee to develop 2 standards, one for material specification and testing, and the other one for structural design. And it's going to be released by public review in the next month or so. Okay. So main non-technical challenges. We have few researchers involved with FRP composites for concrete in Brazil. Limited technical data available in the country. Lack of knowledge of the community about composites in general. And also the industry flagship is basically grids and dowel bars, which is essentially, we don't have a lot of data on that, you know, so they are not very happy. They would like to see grids in the code, and I told them, please wait, let's release this, and then we start looking into this topic. And also variability of materials. There is a manufacturer that's saying that he's using graphene in the bars and to increase the modulus. I really don't know if it works or not, but he's saying he used. And a lot of manufacturers are trying to use polyester-based materials, which we know don't work well. Okay, so here you can see some pictures. the quality of the stirrups, we can see it's not very good in some of the cases. So the scope of the codes, we are working with concrete with strength up to 50 MPa, with or without fibers. We have vinyl ester and epoxy-based bars, bars with surface treatment meeting minimum requirements, physical and mechanical requirements. We allow combination of steel and FRP in the code as well, and temperatures below 80 degrees Celsius. No pre-stressing, no bundles, no hollow bars, or split cross sections in the case of grids. No fire, earthquake, or other type of exceptional limit states loading. No waffle slabs, flat slabs, punching shear, and so on. So the material specification, we have one main document with basic properties, required properties, and 12 parts describing physical and mechanical tests. And we have some original aspects in this code because the ASTM code, it recommends for qualification of the, not for qualification, for quality control, that you have to measure the TG of the bars. But it's not easy. We don't have a lot of equipment. We are a poor country in South America, so we are trying to adapt to this and try to use absorption results and apparent longitudinal shear to measure the quality of the matrix. So it's another way to try to measure that, although we understand that it's not perfect, but it is what we can do at this point. It's the best we can do, okay? Also, we are adopting a tensile test with reduced free and anchorage length. This is for structural design. We also develop our own aggressive environment classes with recommendations for strength and minimum cover. Our codes are also more like the European codes. We don't apply the partial factors to the strength equation, but we apply to the loading and then to the material strength. So we had some constraints while trying to calibrate the safety factors. So we have to add an adjustment factor to account for the brittle failure. And you see that we have a safety factor also for the FRP. And the calibration was done for reliability index greater than 3.8. So another thing is regarding uncracked and cracked stiffness in structural analysis, because in the recent released ACI code, you guys use the uncracked stiffness to obtain the bending moment distribution, but it may be quite different if you consider the cracked stiffness. So we try to include a recommendation based on this. Also, we made some recommendations for strategies for ductility, because it's a main issue. People try to put the FRP down, just saying that there is no ductility, it's a brittle material. So we are trying to include strategies for ductility. In this case, concrete confinement, use of fibers in compression, hybrid reinforcement, and even FRP bars in compression if they have appropriate stirrups to prevent buckling, for example, okay? So it's a simple model for bending, nothing new here, just it's a model based on the European approach. The shear, it's similar, I think, to the ACI, but we change a little bit the VC component because we try to make it more similar to our reinforced concrete code, okay? And fibers are not considered, but it's something we want to do, to include fibers for as a resisting component in shear. Also for deflection, we are adopting the same equation as the ACI, but we are considering lower momentary cracking, okay, due to the soft introduction of a soft point inside the material. Also, we allow for the reduction of long-term behavior if you position the steel in the compression zone, okay. Also for the cracking verification, we account for fiber for fibers to reduce the crack opening by modifying the mean tensile strength of the concrete. Okay? So just concluding here, the Brazilian code results from 5 to 6 year work. It's a pretty modern code, original in many aspects, but not perfect. Yeah? And code will be really important to spread the knowledge about FRPRC and its safe use. And the committee will reunite again in the second semester of this year to continue the work, talking about grids, dowel bars, fire, punching shear, etc. And it's a merit of a very small group with very limited resources, but focused, highly motivated, and hardworking. So thank you very much.